Hey y'all, Mr. Eberhardt here. Welcome to your first lesson of your new unit. Our topic is perimeter and area of figures. And our essential question is, how does perimeter and area differ in irregular figures specifically? So take a second right now, pause the video if you have to, jot down your topic and your essential question. And a quick note, if you would like to download the PDF version of this and print off a copy for yourself, there is a file in Schoology because some of the pictures we're going to draw are kind of complicated and they've got graph paper behind them. So I would recommend you either print that off, or if you don't have that available to you, just draw rough sketches of our pictures and it's not the end of the world. So go ahead and pause and do that, and then hit play when you are ready. All right, our first definition here is perimeter. I'm sure most of you remember this from elementary school. Perimeter is just the sum of all sides of a figure. It's like you're putting the fence around your yard. Don't forget, sum means addition. It just means you're going to add together all those sides of a figure. So let's look at a quick example of that. Here is a rectangle. I tell you the length down here is 5 centimeters, and the width over on the right is 2.3 centimeters, 2.3. So a couple things we have to realize here. We want to add together all sides of the figure, not just the two that I tell you. So remember your properties of rectangles. If the width of the right side here is 2.3, the width of the left side would also have to be 2.3, in this case centimeters. I tell you the length on the bottom side is 5 centimeters. That means the top also has to be 5 centimeters. So don't forget the elementary school skills you learned about rectangles, because they're going to be helpful here in middle school as well. Now that we've labeled all 4 sides, let's actually calculate the perimeter. So we're going to add together all 4 sides. Let's start with the 2 blue sides here, 2.3 plus 2.3. And then we're going to add the 2 lengths that we labeled in red, the 5 centimeters and the 5 centimeters. So if we do that, we're going to get 4.6 plus 10. I just added these 2 together and then these 2 together. And if we combine those, we get 14.6 centimeters. Don't forget, you are allowed to use a calculator if needed, but I think you'll find a lot of these don't actually require that. So go ahead and pause if you need to. Move on when you're ready. All right, here's our first irregular figure. Like I said, these pictures get pretty complicated, so if you didn't print them off, just draw a rough sketch the best you can. It's not the end of the world. Just do what you can with what you have. So our question asks us to find the perimeter of this irregular figure, so you can see it outlined in green right there. And remember, perimeter is like we're putting a fence around this figure. So I've already drawn these green borders around it. All that's left to do is count how far around the shape that is. So this distance right here would be 1 unit. In this case, it doesn't tell us. We're just going to call them inches, just so we can refer to them in the future. So this distance right here is 1 inch. Same with this. That's another inch right there, and so on. So let's go around and count all along the outside of this figure. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Whew, I'm going to pause right there. Just make a line and write 13 in case we lose track a little bit later. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Pause again right there in case I need to double check. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. So in total, the perimeter of this figure, P equals 36 inches. All right, as you probably expect, after talking perimeter, we're going to talk about area. So our goal is to find the area of this figure. And remember, area is basically how many things you can fit inside of like a rectangle, for example. So you count the number of boxes inside of the figure. Here's the same picture we just had from before, so you can reuse the same picture. I also have a reminder over here. Don't forget, we're going to label area in square units. So for example, inches squared. And we're going to assume again that one of these is 1 inch, which means one of these squares is 1 square inch. 1 inch squared. So each square is 1 inch squared. We're going to try to figure out how many of these squares fit in this shape. So I'm just going to count 1 square at a time. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So far we're at 12. Just going to jot down the note for this little corner here. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm going to pause there. We got 24 right now. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. We're at 36. And lastly, 37, 38, 39, and 40. So we end up at a nice round number, which is 40. And again, we're going to assume it's in inches, so I'm going to label my answer as inches squared. Shape here doesn't quite follow the lines like our old figures did, but that's okay. Remember, our goal here is to find the perimeter and the area, but it's just an approximation. So your answer might be a little bit different than your friend's answer, and that is totally fine. Just try to get as close as you can. So before I find either of them, the first thing I'm going to do is just try to trace around the shape following only straight lines. So I'm going to start down here. And I'm going to do my best to, as closely as I can, trace this heart shape, but stay on the straight lines. So here, I'm going to go over this way right here. Now, when I'm deciding, I can either go here or here. I can see that less than half of the shape is filled in with paint. So looking here, like I said, these are my two options. Less than half of this square is filled in from the heart. So I'm going to decide to go on the inside here, that direction, instead of the outside, because I'm going to be closer to the line if I go on the inside. And I'm just going to keep following. I would say this is slightly more filled in by the heart, so I'm going to go on the outside this time. This is where you can sort of see why your answer might be different than your friend's. So I'm going to keep using this strategy here. Now less than half of that is filled in, so I'm going to go on the inside, outside, all the way around. Inside here, keep going. And more than half, we're just going to keep going around. Inside there. Apologies if my straight lines aren't great. I'm doing my best. And then we're going to meet up right where we started. So this grid line that we just drew is going to help us find both the area and the perimeter. Let's do perimeter first. So we'll do perimeter first right there in green. So let's count the outside just like we did with our other shapes. So we got 1, 2, 3, 4, 5. Oop, missed that one. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So my perimeter right now that I got is 28. And we'll just assume it's in centimeters this time, even though I know I did a bad job of telling you what they were. Let's just say it's 28 centimeters for that. Area we'll do in a different color. Let's do area in blue. Area is the number of total squares inside the grid. So since we've already drawn our outside grid, we're just going to count each square as one, in this case, square centimeter. So I'm going to go through and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, and 38. So my area in this case is 38 centimeters. And don't forget, all of your areas should have square units.